Hi there students, welcome back. So we will be progressing with the example that we started on. I've tidied up the screen a bit as you can see, but I've written down the important things that you would also write down when you approach an hypothesis test. Just to remind us about what we learned in class, I'm just going to toggle to the screen of the slides that we've gotten as part of our class handouts. Step number 1 in the basic steps to hypothesis testing would be state the null hypothesis, and step number 2 would be state the alternate hypothesis. So if we go back to our worksheet, we would say the null hypothesis, and please remember the null hypothesis always states the claim on the population parameter. So mu is equal to 0, negative 0.545. And then the alternate hypothesis, which is step 2, will state the opposite of what the null hypothesis states. So it would say not equal to 0, negative 0.45. Just want to tidy that up a bit. It's bugging me a little bit. Oh, not much better, is it? But anyway, let's move along. Step number 3 then is have a look at or determine your alpha. I paused there because alpha really can be given to us in 3 ways. In this case, we are told 5% level of significance. Now, what 5% level of significance also means, if it's 5% level of significance, then it means it is 95% confidence. So your alpha can be given to you as a confidence level, as a level of significance, or it could be given to you as a straightforward alpha. To calculate the alpha using 5% level of significance or 95% confidence, with 95% confidence, what you would say 100% minus 95% would give you 5% level of significance. 5% level of significance would be 5 over 100, which will give you an alpha of 0.05. So the alpha in this case is 0.05. And what the alpha really tells us is where the critical values lie. To establish the critical values, I must understand normal distribution. But I won't run ahead and discuss that yet. Let us refer back to our class notes and see what is on the cards for step number 4. Determine the sample size. Our information in our question gave us the sample size, and I've written it down there as 25. Step number 5 would then be determine the appropriate test statistic, and we've done that in the previous video or screencast that we've seen. Step number 6 would then be set up the critical values and divide the rejection region from the non-rejection region. That's what it's supposed to say. So what does that mean? We know that we have used an equal to sign in our null hypothesis, which means that our alpha needs to be divided into 2. That means we will have 2 critical regions. Probably it's not a good drawing, but please humor me. We would have this on the far left would be a rejection region. On the far right would be a rejection region. And in the center would be a non-rejection region. What separates the rejection region from the non-rejection region is a critical value. And in a two-tailed test, we have 2 critical values. That's also a critical value. So how do we know what that critical value is? We use our alpha. As we explained, alpha is divided by 2. So the new alpha for our two-tailed test would be 0.05 divided by 2. 0.05 divided by 2 is 0.025. And that still doesn't tell us our critical value. We then need to take it a step further and understanding normal distribution. We get this value, we get it translated using the Z table and understanding the principles of the Z distribution table. I'll draw your mind back. I'll ask you to try and recall what we learned in Stats 3. The area under this table is 1. And we know that the area, that's not a good representation of the mean, but the area on either side of the mean is 0.5. The normal distribution is a symmetrical distribution. So what we see on the one side is equally true for what is happening on the other side.